Mr. Benson here with the next video on solving problems with linear equations. Now this involves the way we can describe a lot of real-world activities with linear equations. So things like earning wages or hiring things like cars or other equipment, renting houses, taxis, things like that can all be described with linear equations. A lot of financial things are linear, so simple interest, which we've looked at before, is another example. When you go into more complex things and a lot of natural things that we can describe, they tend not to be linear. But that's okay, this is a good starting point. So the sorts of problems that we might look at, hiring a taxi. So a taxi costs $3.20 to hire plus $1.60 per kilometre. How can we figure out the cost of travelling 15 kilometres? Now what we need to do with these is we need to start off by thinking about what are the quantities that we're going to that we're interested in, basically. Now the cost in this equation, this is obviously what we're trying to find. So this is the answer here. So I'm going to just call that C. Now the number of kilometers is another variable, because in the question we're asking what it would cost to travel 15 kilometers. Now I'm going to call this D for distance, because that's a sensible name for it. And I know that it costs $3.20 to hire, and then it's $1.60 per kilometre. So what that means is I'm going to have to multiply my distance by $1.60. So my equation is going to start looking like this. I've got my cost equals, now normally I would write the term that has a pronumeral in it first. So it's $1.60 is 1.6 times D, so I'll just put 1.6D plus my fixed value, which is $3.20 or 3.2. Now this is a very common form of linear equations that you'll see a lot as you go through maths. Now in this particular example, we're told a distance, so we're told that D equals 15. So the skill that we need to use here is our substitution, so I'm going to replace D with 15, so it's 1.6 times 15 plus 32. Now in this case, I'm not solving an equation so much anymore because the C is already the subject of the equation. So all I need to do is use my order of operations to calculate this correctly. Now you know that we do multiplication first, so 1.6 times 15 is 24 plus 32. So my cost will be 24 plus 32 is $56. Okay, another example that we could look at, when 6 is subtracted from a certain number, the result is 15. Now, often with this style of question, it's not that the mathematics is very difficult, but the way the question is asked is the most confusing part. So, let's think about what we know and what we don't know. So we know something about 6. We know 6 is subtracted, so at some point we're doing minus 6 from a certain number. Now this certain number we don't know, that is going to be x. The result is 15 equals 15. Now so I know I've got a minus 6 in here somewhere, I've got x somewhere, and I've got 15. So 6 is subtracted from a certain number. The nicest way of writing that is x minus 6, and the result is 15. So now I have an equation that looks very much like everything we've done previously. So I'll go and I'll use the techniques that we've been practicing for a while to solve this one. So again, we know that I will add 6 to both sides, and these will cancel. What I'm left with is x equals to 21. So the trick with these is not so much the mathematical side of things as it is interpreting the question. Okay, another example, 3 more than 7 times the number is 0. So is 0 equals 0? 3 more would mean plus 3. 3 more than 7 times a certain number equals 0. Well, a certain number again is x. 7 times a certain number is 7x. So we would write 7x plus 3 equals 0. Then we would just go through our normal steps to solve this sort of equation. So again, subtracting 3 from both sides, cancel what's on that side. So we end up with 7x equaling minus 3. and so we will then divide both sides by 7, doing the opposite operation at each stage, and so we end up with x equaling minus 3 over 7. Okay, looking at another example. When dividing a certain number by 2, the answer is 4 more than that certain number. Now this is an interesting one because we're talking about this certain number, which is going to be x. We're actually talking about it twice. So we may end up with a situation where we have more than one x in our equation, but you've looked at examples where this is possible. So when dividing a certain number by 2, so x over 2, the answer, so equals, is 4 more, now that would be plus 4, than that certain number. So x over 2 must therefore be equal to x plus 4. Now this one we need to solve just following the steps that we've looked at previously. So the first thing I'm going to do in this case actually is to get rid of this denominator over here, because like I've said before, if we can avoid working with fractions, we'll usually find it a little bit easier. So I'll get rid of that first, so multiplying everything by 2. Sorry, I hit the wrong button there. So 2 times this, 2 times all that, these cancel. What I'm left with then is x equals to 2x plus 8. Then I'm going to get my x's on the same side. Now in this case, although I'd normally take the smaller number of x's away from the bigger number of x's, it's often confusing if you end up with nothing on one side of your equation. So what I will do is I will take away the 2x from the right hand side. So I'll go minus 2x to either side. These will cancel. Now x minus 2x is minus x. So the only problem in terms of making things a little bit more difficult is now we have a negative sign here. Now there's a couple of ways you can think about this one, which I've mentioned before. If you've got minus x, remember it's the same as minus 1 times x. So we've got x being multiplied by minus 1. We can think of this as, so the opposite, sorry, would be to divide everything by minus 1. On this hand side of the equation, the left hand side, they will cancel. On the right hand side, 8 divided by minus 1, well, we know what we get when we divide a positive by a negative. We will get a negative number, so we'd get x equal to minus 8. As you get more confident with this, what you'll also see is just that if you've got a negative x and you want to make it a positive x, you just change the sign of everything on the other side of the equation. That's perfectly good as well, as long as you remember to change the sign of everything. Now sometimes you'll come across examples that are trickier because they are often best thought about as 2 separate equations. Now this is an idea that we're going to explore a lot later when we look at 2 equations at once, and it's called simultaneous equations. But we can start to think about it with some of these algebra questions, and I'll show you how you can solve them. So if we start off with a question like this, now I'm 32 years older than my daughter. Now 5 years ago I was 9 times as old as my daughter. So from this information you could figure out my age and my daughter's age. So what we need to do is we need to think about how we're going to put this information into some equations. Now the only thing about this is that there are actually 2 ages that we're talking about. So there's my age, now I'm just going to call this y, and my daughter's age, which we're going to call x. So we have 2 unknown quantities, which is a little bit trickier. Now we'll start off with our first sentence. Now it says that I am 32 years older than my daughter. So 32 years more would be plus 32. So you could say that y, my age, is my daughter's age plus 32. Now that's our first equation, but as you can see, well, there are 2 things we don't know, so we can't figure out either of them at the moment. Now then we're going to have a look at the next sentence and think about what this means. Now 5 years ago my age was 9 times my daughter's age. So what we've got to think about is how we would describe how old I was 5 years ago. Now my current age is y. So 5 years ago is minus 5. So my age was y minus 5. Now we're also told that this was 9 times my daughter's age at that time. Now this also means that we've got to think of my daughter's age minus 5. Now 9 times that. So what we've got now is two equations, each with y and each with some x's in them. Now I'll show you how we can start to do some calculations with these to get things a little bit easier to work with. The first thing we'll do though is let's simplify this second equation because it's a bit of a mess. We've got numbers all over the place, we've got brackets that are probably easy to get rid of and things like that. So we'll do that. So the right hand side of the second equation, so in fact I'll call these equations 1 and equation 2. So the right hand side of equation 2, now we're going to carefully expand this using crab claws or whichever expanding technique you are fond of. Okay, so we're going to expand this. 9 times x is 9x. 9 times minus 5, 9 5s are 45. A positive number times a negative number is a negative number. So now we've got y minus 5 equals 9x minus 45. Now what I would like to do is get all my numbers together. So it makes sense to get the small numbers here and put them with the small amount of numbers here, and I'll put them with the bigger amount of numbers here. And so what we're going to end up with as they cancel is y equals 9x minus 40. Now what we can do with these, and this is the whole trick with simultaneous equations, is to remember that y represents my age at the moment. And so y is the same value in this equation as it is here and here and here. So at all points in both these equations y is the same. What that also means is that if y equals 4x plus 32, it also means that this y equals 4x plus 32. Which means that x plus 32 must also equal 9x minus 40. So we can rewrite this as a combination of the two equations. So x plus 32 equals 9x minus 40. So then we can combine our two equations and we should be able to figure out what the answer is. So this is the one where you've got pronumerals on both sides and you'd like to get them together. Now as they're both positive, I would always take the small number of x's away from the big number of x's. So they will cancel. We're left with 32 equals 8x minus 40. Then I'm going to get my numbers all on the one side of the equation and away from the x's. These will cancel and I'm left with 8x equals 72. Now I'm just swapping those over because we want the x on the left hand side, just because we do. Last thing here, as the x is being multiplied by 8, we'll divide both sides by 8, cancelling the 8's, and we're left with x equals 9. So the answer to this question would be that my daughter's age is currently 9. So you can see hopefully that sometimes you'll get questions where you can express them as two equations, but as long as you remember that if you've written the equations out correctly, the pronumerals are equivalent to each other, so we can combine the two equations.